Welcome, or hopefully welcome back to the Reliability Matters podcast, the podcast where we dive into the technologies, methodologies, and best practices that ensure reliability in electronics manufacturing and beyond. I'm Mike Conrad, and I'm delighted to have you with us for another insightful episode. Today, we're exploring the transformative topic, AI-based inspection technologies. Artificial intelligence is revolutionizing how we detect, analyze, and address defects in the electronics assembly process, combining precision with unparalleled speed to unlock new possibilities for efficiency and reliability. My guest today is a leading innovator in this field. Priyansha Bagaria is founder and CEO of Loopr AI, a company at the forefront of AI-powered solutions for manufacturing inspection. Priyansha holds an MBA in International Business and Global Management, a Bachelor's of Engineering degree in Computer Science, and she held a fellowship in Data Science at Cornell University. Her academic background, coupled with her entrepreneurial spirit, has positioned her as a trailblazer in applying AI to manufacturing processes. In this episode, we'll explore the advancements Loopr AI is spearheading and how AI inspection technologies are reshaping traditional methods and the tangible benefits AI offers to manufacturers striving for excellence. Stick around. This is going to be fascinating.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Hey, Priyansha, how are you?
I'm great. Thank you, Mike, for having me today.
Well, thanks for being my guest today. I'm looking forward to this conversation. I find everything AI to be fascinating. But I'll start off by saying this. I do think AI has been given the wrong name. I don't have a problem with AI, but I think the acronym should be more described as acquired intelligence rather than artificial intelligence. Because today there's a lot of, in layman terms, there's a lot of fear associated with AI. And I think part of that fear is just its name, artificial. Considering how AI learns, it learns from every published work known to man. Anything that's been in a library or in a technical journal or on the internet or wherever has been reviewed and is being reviewed. And to me, that's how we learn when we go to college, when we go to school. That's how we learn. We read and we hear and we digest and we discern, and then we come up with our own thoughts, hopefully. But there's nothing artificial about the way we are educated. And, the computer models that do the research just do it way faster with a lot better retention than we have. So I'm not sure where artificial comes in. I think it's more acquired. Now it's generative, so it then forms, the computer version of an opinion, but it's all based on rules that we have given it and research it has done. So it's to me, some of the applications could be scary, but the tech itself is not scary. I find it exceptionally beneficial, and I think we're just scratching the surface in terms of its capabilities. People start companies for, basically, I think it boils down to three reasons. Reason one is they have a novel idea that's never been done before. I'm thinking of the light bulb, for example, Thomas Edison. And they introduce something completely novel. That's exciting. That's revolution. But we live in an age where we see occasionally revolution, but it's really evolution. Even AI it seems revolutionary, but it's really an evolution of computers' power and memory and speed and all that. Then there are companies that they figure there's space for another player. Maybe they're not better. Maybe they're an also-ran, but they're just kind of piling on. That's probably the majority of business startups. It's like, me too. And then there's something like your company, Loopr AI, which is the result of having a problem and searching for a solution to the problem. Now, your family owns a business that makes insulation sheets. Is that correct? And they had a problem with the manual detection of air bubbles. I assume it's an adhesive process of some sort, right? They have to stick these insulation sheets to a surface, and if there's a gap, it's not going to be quite as insulating as it should. I'm guessing. So they had a problem with how do we detect the bubbles before we ship it out to a customer. And I'm adding that in my head. I think that's probably true. Judging by your reaction, you're like, yep, that was the problem. And that kind of spurred the thought process of, can we come up with a better way to inspect? And was that kind of the genesis of Loopr AI?
Yeah, so you got all of it very correctly, Mike. So I think in my case, the reason of starting the company was something that I saw firsthand, a problem there was something we had to deal with, and there was no real solution that we could find at that point of time. And that stayed with me. And I've realized that's not, that I saw it for the first time when I was working for my dad's company. But then I saw it again when I was working for this largest CPG customer, and I saw them struggling at it. Just the scales were different, and then no, when I started finally thinking of having a solution to solve this problem, I spoke to a few other manufacturing companies, and I saw it resonated with all of them. So it was like, this is something which has been around for a long time, and it really needed a disruption. So as I always say evolution and disruption is something that goes really hand in hand. And that's just a word that, you always like starting something which is like, nobody has done before. That's very rare now, right? Like, but it's the where I feel the biggest invention happens in today's time is making something, easier and more efficient for people to use. And that's really where, where we are targeting, and we are working on the
Right.
company.
And I should point out that your company is not dedicated to just one space, right? To one industry. I think you consider yourself an AI-powered inspection company or equipment provider, which can go to a lot of different industries. What types of industries do you currently serve, and how do you see that expanding?
Yeah. It's funny. Anything you make, right? On my table right now, I see pen, paper, books, anything practically you have, or like even a cup. Anything that you make has to go through an inspection process. Now, this is very fascinating, right? Because there's so much of like technology, or there's so much of nuance that a company has to find in order to make sure that the customer gets the right product, and they have the right product in their hand, and they get to use the right thing, right? So technically inspection is something that's a part of any industry you talk about. But again, in terms of how did we get started with, it's always about who were the first companies who showed interest, and they were like, okay, no, this is, if you can solve this problem, like who came our way the first, in the beginning. And I think for us, it has been automotive, it has been aerospace, it has been chemical, and again my dad's company, which is on adhesives and rightly said, and then there is general manufacturing to a bit of it. So I mean, the top three are chemical, automotive, and aerospace. But then we are doing some work for defense at this point of time. We're also doing some work on ECB industry to help with inspection over there. So it it's not like we trying to focus on one. It's just that even when you talk about automotive, there's chips that's being used in a car. So technically, every industry has a lot of overlap with other industry, and you kind of, it's very easy to expand across the spectrum. But yeah, like the focus is automotive, aerospace, and chemical, general manufacturing for now.
Yeah, even though you mentioned three industries, each of those industries has tentacles that go out into, 100 of different, or at least different directions, right? And as you said, there's a lot of commonality between those industries. Aerospace and automotive are becoming very similar in terms of their tech.
Yeah.
Not so much their redundancies, but
And
certainly their tech. Can you share just an overview of how AI-powered camera systems are currently being used to detect defects in materials and or products? Obviously, you're using cameras because it has to see. That's its eyes. Are they super high resolution cameras? Are they, standard off the shelf industrial cameras? How much is the camera? How much is the AI? Is the AI able to use a variety of different cameras? Does it have? Is it very particular? Is it fussy? Just kind of give me the overview of how your company manages the marriage of the input coming in and then the discerning that goes on within the AI model.
yeah. So there are two scenarios that where we see our systems being used primarily. One is a co-pilot approach. So, for example, I'll give you, I'll talk about two different use cases. So one is we're talking about a high precision medical surgical tool manufacturing company, and they make these endoscopic surgical, suture anchors, which are like couple of microns in size and extremely precise. And you can imagine to look at those under a microscope, like thousands of them in a day, it's a crazy job. And in that scenario, what we're doing is we have a co-pilot approach where the inspector puts the part under a microscope, and we get the image of the part from the microscope on a screen with our application running, and it shows it this is good and bad. So now somebody doesn't have to strain their eyes looking under a microscope for like so many hours in a day, where now all they have to do is put it below, look at the screen, and it says good and bad. So that's really, that's one scenario where it's like a co-pilot approach. Now again, just to give another example in the same scenario, we are looking at assembly verification. So a human operator, assembles a part for a leading trucking company, and they basically used a system to make sure if the part is correctly assembled, if it's missing any part, or really looking into missing components, incorrectly assembled parts. So again, it's basically a human in the loop. So human does a assembly, they used a system to do the inspection, and then so we call this as a co-pilot approach, where there's always a human in the loop. The second part of it is autopilot, where it's a continuous process monitoring. So for example, a leading chemical manufacturing company, they make these powder chemical, and it's when the chemicals are getting, like when it's in the process of mixing, it might have, it's either over extra heated up, or they have some foreign object particles, and that leads to the change in color of the chemical, and they only get to know this end of the line. So now, if imagine if the if it's making bad parts, you will not know till the time you have the final product. So in that case, we have a camera which is looking at the mixing of the chemical, and there's no human in the loop. So as soon as it identifies the color variation, it sends a notification, which is connected to the and-on board. So the operator knows that the bad parts are coming in. He has to stop the line and he has to fix it. So, or, we can look at integrating this to a conveyor belt, like to a PLC system. So as soon as it identifies bad parts, it pushes this out of the line. So these are where, or you can use it with respect to a robotic arm. These are complete automated scenarios. And then you have a co-pilot approach where there's a human in the loop. Now, in our case, we are hardware agnostic. So for us, we have worked across different cameras. We have used a $200 camera to like a $2,000 camera. We don't want to, if the real power lies with the software. Like nowadays, the cameras are so advanced that they are already so high in pixel that you can have really, really good quality images coming out of a very, cheap, off the shelf,
Yeah.
$200 camera. You don't
Consumer
need that.
consumer cameras now have. I'm sure this camera probably has enough power
It,
to
I mean,
feed a reliable
cameras,
image. Yeah.
the best cameras you can ever think of, right? Like that's literally in your phone now. So yeah, like for us, it's about if we can automate, if we can do the job with a $200 camera, we don't want to make our customers spend a lot of money to really, go about very expensive hardware. And yeah, I mean, if that answers your question.
Yeah. What are I'm going to morph a question a little bit. What are some of the most common types of defects that your experience sees, and what are the easiest and the most difficult types of defects for this type of technology? So it's kind of two questions in one. What's most common, and what's the easiest and the most difficult?
Yeah. So I would say anything which is visible and discernible to human eye, it's possible to use the system to basically do the identification. Some of the common ones are like scratches, dents, blisters, color variation, missing components, labels, missing labels, incorrect components. These are the ones that we have seen very common across our customers.
Hmm.
The challenges, of course, some of the challenges are when you talk about metal parts, the reflection of the light.
Mm.
If it's something which we always tell our customers, if it's something which your inspectors are not able to detect or identify, you can't expect AI to do that job, because unless and I mean, and AI cannot do a great job when it talks about geometry, like measurements. You have a simple scale which can do a better job than using AI to do the you know to identify the measurements. It can give you a like an approx value, but it's never going to be as accurate as your scale. So that's again something that we never ever suggest our customers to use AI for. So I would say metal parts has been a little tricky for us in the past, but
Mostly because of the reflective nature and optically. Is that the main challenge of that? Yeah.
that has been one of the biggest reasons. And I now we have played a little bit on with the lighting, and that definitely helps. But it's like if you're looking at something which is extremely precise, and like something which is very hard for naked eye to identify, there's no point to waste a lot of time using AI system for those.
And I would assume, when an AI system is connected to a camera, it's not necessarily a type of camera humans would use to take selfies. It could be an infrared camera. It could be uh, X-ray images and things like that. Uh, when when a customer approaches you and says, "Hey, we want to integrate AI into this inspection process," whether it's Copilot or autopilot mode, do you basically install your tech on their existing system, or are you a complete box build kind of solution in a box thing with your cameras and your hardware and your conveyor or whatever the case may be, or do you just go in and integrate?
Yeah. So whenever a customer approaches us with a problem, there are two scenarios that they'll be currently doing. Either they have a completely manual inspection process, or they're using a traditional vision camera, which is not helping them solve the problem, right? So in those two cases, either if it's a completely manual inspection process, then we do help in help the customer in identifying the camera. So we start from there. What camera can you use? We understand the problem statement first. So the first step is very basic, very simple. We ask the customer, take your phone and go record and show us what you're looking for. Show us
Mm,
some good parts, show us some bad parts. It's as simple as that. And everybody has a camera, phone camera. So we're like,
sure.
hey, go there, show us what we are looking for, right? Like what we are getting into. So it starts from that. We understand the problem that the customers are the subject matter expert of their parts, right? We will never be. We are here to provide this solution that's going to help them do a better job in their manufacturing, but we are never going to be. I will never know how a truck is assembled or manufactured the best way. So we always try to understand as much as possible on, through the customer's lens, how important those defects are. And then we always ask the customer, if you have 5 big defect classes, identify the top three, because you're not going to conquer, you're not going to climb to 10 in a day. You want to start with 5. That would itself be start giving you an ROI and much better results. And then we look at, the next 5 steps, but you want to focus on the first 5 steps. So we look at we ask the customer always to identify what the top 3 issues are, and then we help in identifying a camera that they can use. They can get that going. With that, we start taking a sample of 5 to 10 videos, which is roughly 400 to 500 images, because a video is just images per frame. So
29.97 frames per second.
That's correct. Always say 20. So yeah,
We'll round up. The geek in me says 29.97, but it's 30. Yeah.
We always say take somewhere between 5 to 10 videos, or give us three 300 to 500 images. And then image should be a collection of both good and bad parts. So it should give us a sample size of what a defect looks like. And then we ask the customer to highlight the defect very early on, label a defect for us. And for few images, right? We don't expect the customer to go through all 300 to 500 and sit label all of it. So we'll ask probably we do 10 of those. So we know exactly what a defect looks like. And then we replicate that across that image set that we have. And we divide that image set into parts. One is a test data and a train data. So we use the train data, that a certain percentage of those images to build the model. And then we test it on the remaining images to see the performance of it, like an accuracy level. How well is it doing on that? And then after that, we basically deploy this at the customer end, and then we train them. We start making them use it in production along parallelly with their existing process. And once this starts, and I can tell you with our experiences with all of our customers, we have seen 95% plus accuracy in very early stages itself. So it's very promising for them. And then we always see, once you get to a point where you feel comfortable, it's you always have to think about AI is when you hire a new inspector on the factory floor. You don't give that inspector, you don't let that inspector be like, hey, this is your playground, go do whatever you want. And,
Right.
you just start doing inspection. You have that person shadow somebody for some time, the most experienced guy on your factory floor, learn the trade. And then at one point, right, that person has to sign off on this person, and then they can operate independently. It's the same process which we have with AI.
And I would imagine, too, the model needs to be trained on kind of a threshold of what is, at what point is something a defect. So let's talk about, in the electronics world, a component being, perfectly placed. If it is 1 degree askew, I think arguably no one's going to reject that. If it's 2 degrees askew, probably no one's going to reject that. If it's 90 degrees askew, it's not even soldered. So that will be a clear reject. Do you rely, I assume you rely on your customer's input to create that threshold of it's not perfect, but it's still okay, versus no, we're past it's okay mode, right? Can it also be programmed instead of a, green, red? Can it be green, yellow, red? Can it be, maybe you want to take a second look at this? Maybe it's not quite completely determinative, but it's worth a second look. I guess that's all programmable, right? It depends on what the customer requests. Is that right?
Yeah. So generally, even on a factory floor, the process is, if an inspector sees something and he's not sure of it, he'll call his supervisor. He'll be like, hey, can you see this?
Yeah.
Can you check this for me? Because I don't know, if this is actually a defect, or it's an edge case, or it's something, I'm not sure of. Similar to that, in our application, we give a continuous feedback loop opportunity for the customer. So the inspector can look at the AI is going to give the prediction. the inspector has the power to overrule that, so override it. So they be like, hey, this looks good to me, or this is actually defect that the system was not able to catch. And if it's a new inspector, then there is also a supervisor review mode. So like end of the day, the supervisor can actually go through the inspection that was done and can also, see the performance, or like be like, okay, I agree to 10 of these, but then this one is an edge case. It's good to me. So it's that these are all part of the application. So it's like a continuous feedback loop. So we always look at, you measure the performance of the model using, precision and recall. These are the two common things that we use in AI. But then we also have a real-time feedback loop, which is actually with the human giving a feedback, and then you checking the performance of the model. So there's like a couple of ways we try to make sure that the model is doing well, and if it needs and retraining, like let's say you've identified the performance of the model has degraded or it needs, so then it's a very simple process of taking all those uh, like all those the feedback and then putting it back in the system, and it's like one click retraining. So it just becomes so much easier to educate the system.
Right. So if you have 10 false passes out of 100 tests, then you could submit those 10 images and it will correct itself. It'll get a little stricter in that scenario. Is that something the customer does, or is that something the supplier, in this case, your company would do? Can the customer self-train it, or do they have to call you?
So initially, when we get started with the customer, we do that for them, because we
Right.
don't. When we are talking to quality inspectors or operators on the factory floor who are not data scientists, right? So we help them. But the way we are, we are building our application is, this is something which we are planning to release early next year, where we we are making the whole data science aspect so simple that even an inspector would know what are the pieces you need to click in order to go for retraining. So we want to really get away from having that, our customers have the dependency on us. We basically want them to add, if let's say the application was trained on dents and now they see scratches, that is another class that they want to add in the model. They should be able to do that and they don't need to come to us. So we are working on that feature, which we are planning to release, because it's not an easy thing, right? Like you have to make the data science so simple
Right.
that it needs a lot of effort and R&D stuff, and that's what we're doing at our end. But we understand that to scale across multiple factories, that's just something we don't want to do on our own. We want to provide the customer the tools to basically do that, at their convenience, and have that flexibility.
Yeah, it's amazing how complicated it is to make something simple, right? There's a lot of work behind the scenes. When I think of automated AI systems or AI inspection systems, I think about speed as one of the like, duh, it's going to be faster because AI technology doesn't stand up to stretch its legs. It doesn't take lunch breaks and bathroom breaks and look at text messages and things that humans do. But what about accuracy? Do you have any like average data on how much greater accuracy one can expect when they use a system like this versus 100% human-based?
Yeah. So it's believed that if you're just having a completely human-based inspection, out of 10 times, 7 times you'll get it right, but 3 times you will end up making a mistake. That's just like a universal number that we have heard across, that 70% times a human is
30% error rate with humans.
yeah,
Well,
it
we're
is.
not very good.
In a It's just because, like I said, I mean, there is human fatigue. If you have to do something 24 eight hours a day, you're going to end up with, and I'm not saying that's the case in every company and every every industry, but that's just universally that a human is 70% productive in general with the amount of, in some places it's like, 95, 100, but then they have multiple checks. So they'll have one person do it, and then they'll have, you'll have
Right.
inspections at different phases, right?
Well, humans also suffer from psychological effect. I forget the exact term for it, but it's like a perception bias. If
Yes.
these parts are known to always be good,
Yes.
they will tend to always be good,
Good.
whether they
Yeah.
are or not, because we have this bias going in, this expectation that,
Yeah.
I don't need to look at these too close because it's a waste of my time. And they start playing the odds a little bit,
Yeah.
right?
Yeah.
Where a
That's
computer doesn't care. A computer puts the same effort into every part.
Yeah. And then the second thing is also we need to remember that we're moving towards a time when hiding people for these, specific skill is very hard now. Like you can't have, can't find welders in our region, Pacific Northwest, so easy. Like, everybody wants to do the cool job, like which is like, be on the computer and do the cool tech savvy job. Nobody wants to really do, the real work, which is on the manufacturing or like the hard work. So it's really getting harder to find those people out there. And even if you find them, the new people, it's a learning curve, right? And then a lot of it is also like when they start reviewing parts, there's a lot of subjectivity because we have had people, like I remember in my dad's company, uh, when I was a kid, I had someone who had started then, and I went back like very recently, and I saw the same person working for like 30 plus years, and it's insane, right? Like it's like they're practically there their whole life, and that person I know, I mean, he has seen this part enough that even in his sleep he can say
Yeah.
if it's good or bad. But a new person coming in his team, can he deliver the same, the same level, or it's hard. And with people, retaining people have has never been harder in today's time with the new talent. So with all of these challenges, like getting away from subjectivity, but imagine you can have a system which is trained on your most experienced person and is there. It never leaves. It never takes coffee breaks. So those are like a lot of value. And I think with if you have trained the system well, like a lot of emphasis we give is on the data set. So we want to make sure that the data set covers practically most of the scenario. So like good, bad, and a lot of edge cases too. So the better we can have the data, the better performance it will be with the AI system, and you can easily expect the system to be, you know, anywhere from 90% above, and of course you can make it better with time. So we have customers where we have even looked at 98, 99% accuracy, which is pretty good.
On the subject of making things better with time, what role does machine learning play in training these AI systems to recognize different kinds of defects? And can you walk me through the process of training and fine tuning those models?
Yeah. So machine learning is really the backbone of computer vision models used for AI inspection. Uh, the whole process, I mean, I kind of gave a glimpse of it. So we, you know, collect and label the training set, roughly 5 to 10 videos, 100 to 500 images, divide into training and test, and we basically then train it relevant on different model categories. So we have like segmentation, classification, object detection based on what you're looking for. So if you're you know, looking at something, for example, in some industry, as soon as you find a defect, you're not going to rework on it, you're going to scrap it. So in that case, a object detection model is great, or like classification model. But if some industry you have to rework, you can do the rework. In that case, you need to use something like a segmentation model, which tells you not just that it has a defect, but it'll tell you exactly where the defect is. So now you don't need to waste all that time when it comes to rework. You know exactly what you need to fix.
Yeah.
So it
Am I mixing up terms? When I think of machine learning, I think of the machine kind of getting smarter almost on its own. Obviously, it can't totally be on its own. But is there a difference between programming the model, giving it in our world, take a picture of a golden board, perfect board, and then anything that is not that, is cause for scrutiny. that's how we load the model in ahead of time. Do these algorithms, for lack of a better word, get smarter kind of on their own, or is machine learning just us teaching it when we first program it? You know what I mean? I know in the like Chat GPT world, every once in a while I'll research something and I'll find out that something's not accurate. You and I were talking about that before we went on the air. And I'll tell it, this is not accurate. And I'll maybe throw a few citations in and it'll come back and it'll basically say, yeah, you're right. And I would assume if it hears that response too many times, it will no longer give that incorrect response. It learned from a user input. So I guess my question is, in the integrations that you perform, or at least some of them, is there an opportunity for the user to provide input on a real-time basis that it then learns from, as opposed to finding it made a mistake and then taking more pictures of what the mistake was and then forcing that down its digital throat? You know what I mean? How much of that is intuitive within the use as opposed to being programmed every time something needs to be tightened up?
Yeah. So, I mean, when you just gave the example of ChatGPT, you're still giving the computer an
Yeah.
input, right? Like you're giving a prompt or
Right.
you're giving something. So there are foundation models which we use across industry, but then which we start with, right? Like, so there are some open source, really good models that been available. And then there are, we've started playing with SLM models very recently. We have a big partnership with Microsoft, and they're in the forefront of LLM and SLM models, generative AI models. So we've been experimenting with that as well in the background. So, but one of the key thing is that you need to give that prompt. You need to tell, that you need to give a context to the model, because again, how will it know that
Yeah.
it has to, fine tune it that's on something that Mike likes, right? Like, or what is relevant more to Mike, because
Right.
it's being trained on so much of data set that it needs. So similar to that, when we work with any customer, we need to, give that tell the model that, okay, we're looking at chemical industry, or we are looking at specifically these kind of defects. And after a point, it gets to a point that yes, it starts getting, better and faster. And, it's when we talk about retraining, again, it's not like be retraining like with a
Not
lot
from
of
scratch. Right.
from
Right.
scratch. Yeah. It just becomes so much easier to just take that. You just, how you give a prompt and you be like, okay, look at this specific place and see what's going on. The same way we give a prompt to the system with that feedback. And it's just probably one or two images, right? We're not talking about creating like,
Right.
again,
A whole new
100
library. Right.
with images library.
Yeah, I think you are correct. It's not learning on its own. It's learning based on feedback. I think the ChatGPT model is OpenAI, which
Yeah.
created ChatGPT. They wrote the original code. They built the model. And then the millions and millions of users give it prompts to make it smarter, right? So, if I find an error in your biography,
Yeah.
I don't write to OpenAI and they go and fix it.
Yes.
I just respond to the
Yeah.
to ChatGPT and say, this is not correct. Here's a citation that shows otherwise. And it comes back and says, yep, you're right. And I would assume they write the code so that it won't rely on one input from one customer. I assume if it gets a threshold of, a certain percentage of negative feedback, it will then alter it'll consider it credible and alter it. But I don't think OpenAI needs to go in and change everything. So your customers are able to retrain it
Yes.
with a few extra photographs or whatever the case may be. And yeah, so that it gets smarter the more it's used and the more people interact with it.
Yeah.
What?
And one thing we need to keep in mind here is that when we talk about our customers, we are talking about their proprietary, knowledge, which is something, which is not about, you
Right.
can
You don't
openly
want
use.
it to go to their competitor.
Exactly. You don't
Yeah,
want that to the competitor. Or I have never seen, I mean, not, we have strict data privacy, data security laws with our customers. So
right.
we're not allowed, I mean, we're not supposed to even use an existing customer's data for a new customer, because that's again, right? Like
Yeah,
it's straight from their proprietary data. So it's very different. When you talk about ChatGPT, you're using it something which is as simple as, like like what I'm like my favorite restaurants, or something which is like very generic info,
right.
over to something which can be, very
Yeah,
precise.
your terms of use are a little bit stricter. If you're
Yeah.
in the defense world, aerospace world, you have ITAR, you have all these different regulations. Speaking of ITAR, if someone is regulated from a security standpoint, they generally can't use cloud stuff. It's like edge stuff or whatever. Can your system support that as well, like on premises, as opposed to going up to some super cloud somewhere?
Yeah. So we do support hybrid model, where the train can be on prem or it can be on cloud. In some cases, gov cloud or like private cloud. Most of our customers, when we train, they like it to be on their cloud rather
Yeah,
than
sure.
their tenant, their Azure tenant, and then be deployed on prem, because most of our customers are like, we don't want to have that dependency on 100% internet all the time.
So you use Azure, you use the Microsoft platform as opposed to Amazon
Yeah.
AWS platform.
Yeah. I mean,
So do we, by the way. At my company, we switched from AWS to Microsoft platform.
Microsoft is most trusted when it comes to enterprise
Yeah,
customers, and they have built some really, really good products that we been able to use in our solution. So we really we it's as simple as that. The amount of security layers they put in their product, and if you can just use that, you don't need to reinvent the wheel. It's already
right.
been taken care of. So we
Yeah,
use. And yeah, so we have a hybrid where we train it either on cloud or on prem, and then we deploy it on prem. So the inference happens on prem using the on prem servers, and then you can send these again, deploy this back to the cloud, do all the storage on the cloud, or if it just has to be a complete on prem solution,
right.
that's also fine. We support that.
What types of challenges do customers generally face when implementing AI systems, and how do these challenges get satisfied?
Yeah. So lack of technical know-how and resources, for example, building an AI solution requires a full-time data science, engineering, product team to build, deploy, maintain, and evolve such solutions. And it's not something which is very easy and comes very naturally to manufacturers. Like they are an expert in making their products, but they're not an expert in AI and cloud and data solution technology. We have seen a lot of Fortune 1000 enterprise customers attempt and fail because, again, their bread and butter is not software plus ML. So even if you build a model, it's just 25% of the job. Your QA inspectors, plant managers are not data scientists. You need to package and deploy in a manner which is accessible to them, or they'll never use it, or they'll stop using it. And after that, you need to continue to maintain it and respond to your users' feedback and requirements. And so these all makes it even more complicated when you talk about running it for long term. And manufacturing companies need to start coming up these AI inspection solutions, like their own enterprise software, like MES and MQS, right? Like it's something uh, which I'm sure companies have tried to build also on their own, and they failed. And then they realized that they would rather go to a solution provider who has nailed it. So similar to that, like with inspection, there are companies have tried to build it on their own, but then I think it's you don't need to really build it on your own, but work with smart providers to customize and integrate it within your environment. So that is like how I see this even evolving. Like very recently, one of our last biggest customer, they tried to do it in house for 2 years with a team. They failed. They couldn't scale beyond two or three. And they realize, because there's so many moving things, right? Like
Sure.
that you need to look into. So I think over there, with what we are providing is a big value for them.
So, can you discuss any real world case studies or examples where companies have successfully implemented AI based detection technology, defect detection technology, and what were the results and the key takeaways from
Yeah.
that experience?
Yeah, so I would like to talk about one of the largest forklift attachment manufacturing customer of ours. It's in their factory. They would make these forklifts, which is it's a high mix, low value volume scenario. So in on one line they'll make parts for five different customers, and everybody's specifications were different. So now you can imagine, probably the customer A needs two bearings, two cylinder, but then customer B has one bearing, three cylinders, and the requirement and the specification changes. And they had like multiple people inspecting those parts, and then it's everyone's responsibility, which means it's no one's responsibility
Right.
basically.
Someone
So
else will
right.
do it. Yeah, if I miss it, someone else will get it. And they're thinking the same thing.
Yes, and word sometimes it's funny that the factory manager would always joke like, people are lazy, so they'll see it and they'll ignore it, and
Right.
that those
So
parts would still,
someone else will see it. Yeah.
yeah, so that part would still keep moving on the line. So what we did is they implemented our solution, and they were able to. They noticed that the first month they had 5% defect escapes. That's huge. That's a
Yeah.
big number. And then they started even going in details and looking at what time of the day were these happening, who was working on it, what parts, what was it that was not being missed the most. And then they recently even realized that even some parts were missing the label. That is insane. And these are the information which they were not able to capture. Like there was no real information in hand, right? So if something would get rejected at customer's end, it was always a guesswork. Like, okay, this must have happened, or this, and there's no way that you can actually say with confidence or with data backing that, hey, this was the real issue. So now they've started with all that information that they got. Their next months was they were able to bring down the escapes, so it became like 3%. And then now the next month it was even further down. So you can imagine the impact of the system in extremely short period of time.
Hmm.
That is really what we are talking about in terms of value. I'll just quickly talk about just one more customer. So with this
Sure.
another customer of ours, chemical manufacturing customer, they make chemicals, and again, it's impossible for them to know what's going on, in real time when the mixing is happening. They'll only know towards the end. They rely like 2 weeks back, they had a run, and they had 45 minutes of bad products, and our system was able to test the moment, flag the moment the defect started. So basically, with if they were just in the trial phase of the system, so they had not fully implemented it, but if they would have gone with the results of our system, it would have saved them 45 minutes of scrap chemical, which is like a big, it's bad for the environment. It like they need to, it's a big waste, and then they of course need to remake those products. So again, a big value, like 45 minutes costs a lot. So these are some real numbers that we have seen very quickly since the customers have started using our system.
Yeah, it's kind of like the old business adage: if you're going to fail, fail fast, right? Don't fail, don't fail slowly, because a
Oh,
lot of damage will occur if you can
yeah,
fix it fast. You fail
yeah,
fast, fix it fast.
yeah.
Yeah, that's great. In terms of ROI, and I know it's this is more of a generic question because it probably varies quite a bit from application to application. But is there a typical ROI associated with an investment in an AI-based inspection system? And and what would that ROI tend to be in terms of time?
So we've seen AI-based inspection system to be, to reduce the cost by like 5x cheaper than your manual inspection process. So
Okay.
uh, technically, you can, get the ROI can be in less than a year if it's done well, and if it's again, it's not something that we can generalize
Right.
because some industry, right, like the cost of defect can be massive, like with just what we saw with aerospace recently.
Sure.
When the largest aerospace customer, they've had a really hard time with this. So the cost of defect can be massive. For some, it's it's so again, at the end of the day, if you want to have a technology, you should not go for the technology just for the sake that AI is cool and everybody's talking about it. We always tell the customer it should be really a business value driven approach. So if you see that you're spending a lot of money and it's costing you a lot of money with your current manual inspection processes, and automation can really help, that's really where you should start thinking about implementing AI. But just for the sake that I've heard a lot of Gen AI and Chat GPT, and that shouldn't be the real motivation to try out a technology. Is it
Yeah.
because that won't take you far, for
Right.
sure.
Yeah. 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 Well, these days, with company budgets and things like that, particularly within the electronics world, I don't think anyone's going to spend the money to have fun. As cool as it is, buy a video game if you just want to be entertained by
Yeah,
technology.
yeah,
What advancements do you see in AI inspection in the upcoming? It's funny. I wrote the question as 5 to 10 years. That might actually be 5 to 10 minutes in this world, but I'm sure things have changed since you started talking to me a little bit ago. What, where do you see it going in
yeah,
terms of its technology and its applications?
yeah. So we expect drastic reduction in training and turnaround time of customized models using few shot and one shot training enabled by your large vision models that's being uh, I mean, we've seen the difference with GPT photo on the conversational side. We're expecting something similar on, the vision side, where there'll be large vision models, uh, and probably that layer is going to get so democratized that there'll be just like handful of models that would solve any customer problem. And then it's really going to be about how do you bring that on, how can the ease of implementation, how do you work on that ease of implementation, how can you bring that or package it in a way that it's easily deployable on the factory floor. Second thing is further reduction in data collection, labeling effort, ability to trivially add, new classes, products. Those are again some of the places where we see, technology coming a long way. And then I would say also we're already seeing how forgiving AI is now to, the change in lighting and change in like process condition. But I expect that to become even more like, flexible with
Hmm.
time. But it has already come a long way with what you were able to achieve in 2018, 2019 to where the models are today. I can tell you it has come a long way. Like you couldn't have imagined that, creating a model without like 10,000, 20,000 images minimum to start off with. Now we're looking at 100, 200 images.
Wow.
That
Quite a
itself
difference in scale.
is a
Yeah.
it's a big advancement, I would say.
So your systems right now are primarily camera based. Is that accurate?
Yeah.
Is there any thought of expanding into like acoustic based or chemical based? There are a number of instruments that test certain qualities of
Mhm.
metals and chemical formulations and things like that. In the electronics world, to determine the volume and species of contamination on a board after reflow, ion chromatography is a popular use. And ion chromatography doesn't just outright tell you this is flux or this is mold release agents from a component reel. It gives you a chemical structure, and then you have to compare that to like a fingerprint database almost, where AI can be trained on that. And I could see an AI based system looking at knowing the application, knowing all the different things that come into contact with the board, knowing what its chemical signature looks like, being able to evaluate a ion chromatography report and instantly say, most likely it's X, Y, and Z that are on the board. This is where I would look, as opposed to hoping the laboratory that's conducting the test has experience in your specific application. Do you see that in the future as well, to go beyond optics and go into other input mediums?
Yeah, for sure. So we already, when we say optics, we also already looking into X-rays and ultrasound images, and we just
There you
need
go.
an image format basically. So it'll be like when even NDT, non-disruptive testing, using those images to do analysis. All of that is already possible with our system. Um, the example that you gave, we haven't explored that yet. But if it's something which can be in an image format, the data source can be, if you can put it in like something that can be like, that can be seen.
Yeah, sure.
That's something which the system can digest, and we can work around that.
Yeah, that's
So
how it's done now. It produces a chart, basically, either printed or on a screen, and then the technician looks at the chart, looks at how many weak organic acids or sulfates or bromides or whatever is spiking on the chart, and then makes an assumption.
yeah,
The problem with that test, though, is that if I just went out and bought the equipment tomorrow and started running tests, I would get, depending on the type of samples I'm looking for, I would get a reading. I would have no idea where those, in this case, residues came from, because I'm not familiar with the process. I don't know what these things are exposed to. If I know that, they serve popcorn at lunch, then I can probably get the signature, the chemical signature of oil and, popcorn. And I would be able to go, yeah, your popcorn is making its way onto the board, just as a ridiculous example.
yeah,
Finally, the thing about podcast time is it goes really fast. And where I think we've been talking for 10 minutes, I realize that we're about out of time. So let me just kind of end on this question. In terms of AI in general, this is not in terms of your company in general, but just in terms of AI in general, what are the ethical and regulatory considerations when using AI in quality control or other applications for that matter, particularly in industries where product safety is critical?
yeah. So it's this is an old IBM saying: a computer can never can be held accountable. So a computer must never make a management decision, right? So I think it still holds true. So with all of our customers, we test in production for a certain period, make improvements, build trust in the system, and then over time start, basing production decisions on it. But then you always need to monitor its performance. So AI inspection is a tool which must be used in conjunction with existing processes that are ultimately controlled by humans. We will continue to sharpen and hone this tool so that it improves QA processes by making them cheaper and faster. But at the end of the day, the human is like always going to be in the loop, and the human has to give the inputs and make sure that it's all going in the right direction. So
Right.
it's just the only way how we can basically put a check, and how you can. It's funny when people say that this will replace humans completely.
Oh,
I
I
don't
hope
think
not.
there's ever gonna be a time where that it's gonna get to a point. You would still need somebody to run these systems, even, right? Like, even if you can
And retrain
automate
them
some of
and hone them. Yeah, absolutely.
happy. So you'll always have some kind of human in the loop. It's never ever gonna be that. It's gonna ever get to a point where everything happens on its own. Like, you would still need someone to manage these systems.
Well, it's just like in business. If I hire CPAs to prepare a financial statement, a tax statement, and I sign it and send it into the IRS, I am responsible. Even though CPAs did it, they're more qualified to do it than I am. I'm still ultimately responsible. So the same thing goes with
Yeah.
your example. It's ultimately a human. human has to make the final decision. AI is a tool to help the human, to assist the human in making the final decision, but it is not in itself the final decision.
Exactly. Like, how Excel helps accountant speed up tasks, but they're not going to replace them, to audit books. Like you still have somebody to sign off.
Right.
End of the day,
The accountant will just be more productive and
Yes.
more accurate at the end of the day.
Yeah.
Well, Priyansha, thank you so much. For my audience who would like to get more information on Priyansha's company, if you're watching this on our YouTube channel, look down here where it says Show More, and I'll have a link to Priyansha's company right there. Also, if you're listening to this on your favorite podcast app, go to your podcast app, look for the show notes, and the company information, Loopr AI, will be right there. Priyansha, thank you so much for being my guest today. I'm glad we got together. I wish you continued success, and I'll look forward to talking to you again when, shortly before you're purchased by Google or Facebook or Microsoft or somebody, because that's going to happen, right? You're onto something good. Yeah, I'm sure something like that's going to happen.
Thank you so much, Mike. I thoroughly enjoyed my conversation with you, and these were some really, great questions. And like I mentioned to you in the beginning of the podcast, that I have not answered a lot of technical questions, and I really like what I love about your podcast and your show is that you try to get into the the deeds, like in the inside of how it actually works and how it functions, and which is so helpful, right? Especially for somebody who's looking to implement a solution like this or technology. They want to know a lot more than just having the surface knowledge. So I think that's really what you bring in with your podcast.
Well, thank you. Thanks for the kind words. It's interesting. I know a little about a lot of things. I can sit next to someone on an airplane and have a 30-minute conversation about AI. After that, I'm done because I don't remember anything else. But I'm very fortunate that I get to interview experts, subject matter experts in fascinating fields, and pick their brain and learn a little bit, because where else would I get that opportunity? So I feel like I'm stealing candy from babies here. This is the best part of my job here, is talking to people like yourself and getting educated on technologies, which I find fascinating. I'm a geek at heart. I'm a nerd at heart. So all this stuff is fascinating to me. So thanks for educating me, and thanks for educating, more importantly, my audience. I really appreciate your willingness to be part of this.
Thank you so much, Mike.
Well, that's another episode. Thanks for listening to or watching the Reliability Matters podcast. Don't miss an episode. Subscribe to Reliability Matters on your favorite podcast app. If you're watching this podcast on the Reliability Matters YouTube channel, be sure to like and subscribe to be notified when new episodes are released. We release new episodes on the second and fourth Tuesday of every month. A special thanks to the Printed Circuit Engineering Association's PCB Chat at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating the show. Thanks also for your questions and episode suggestions. Please keep them coming. I love to hear from you. Send comments or episode suggestions to Mike at mikeconrad.com. Just remember, that's Conrad spelled with a K. To learn more about the Reliability Matters podcast, please visit our website at reliabilitymatterspodcast.com. Once again, thanks for listening or watching. Until next time, keep learning, keep doing it right, and remember, reliability matters. I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.